Hello there, Ellison here again. Semiconductors are a class of materials in between insulators and conductors. They have a higher resistance than conductors, but lesser resistance than insulators. There are some properties of semiconductors that need to be noted, like their reaction with temperature. When temperature increases, their resistance decreases, which means they conduct better. Or when temperature decreases, their resistance increases, which means they conduct less. Another very important property that needs to be noted is their reaction with impurities. Depending on the type of impurities like trivalent or pentavalent elements, their conductivity increases in a particular form. So to dive into the study of semiconductors, let's take a little study on electrons and holes. When discussing electrons and holes, we need to remember that like charges repel and unlike charges attract. So every charge is looking towards getting a balance of a positive and a negative. You can use the analogy of 1 and -1 and the balance being 0. When two of them add together, you get 0. So a positive is looking forward to a negative to form a balance of 0. Now let's remember also that electrons are negatively charged. Electrons are negatively charged. So we have holes. Whenever electrons move away from a point in an atom, that point becomes empty. So if you had an electron in this point and it moves away to another point, this point becomes empty. This point, we call it a hole and we give it a positive charge because this electron was at a balance in this point, but it moved away to form another balance somewhere else. So it's made this point imbalanced by removing the negative, making here positive. So this becomes a positive charge of equal magnitude to the electron. So holes are positively charged. So let's look at the types of semiconductors. So when looking at types of semiconductors, you think about the purity of the semiconductor. The first we think of is the intrinsic semiconductor. The intrinsic semiconductor is the pure semiconductor that has no impurity in it. It is very pure, and whenever you connect it to a battery like this, let's say this is the intrinsic semiconductor and you connect it to a battery, this is the symbol for a battery. You have electrons and holes moving. The negative charge here moves the electrons, repels the electrons here, and the electrons move in this direction. Electrons move in this direction, and because of that, holes come towards this direction because these holes are also repelled by the positive charge. But as the holes are coming here, electrons from the negative part of the battery are combining with the holes, forming a balance. So this is always continually balanced. So remember we talked about improving the purity, the conductivity of a semiconductor. That's when you add impurities. Adding of impurities is called doping. And when you dope a semiconductor, you have what you call an extrinsic semiconductor. An extrinsic semiconductor, okay? It occurs by doping, extrinsic. And it's done by doping, adding of impurities to form a more conductive semiconductor. So now for doping, we have two types of doping. We have the addition of pentavalent elements and addition of trivalent elements. When pentavalent elements are added to a pure semiconductor, you have an N-type extrinsic semiconductor. N-type. N-type means that it has more electrons because pentavalent are donors. You have more electrons in the combination, causing it to be more negatively charged and more conductive. And whenever you have a trivalent being used to dope a semiconductor, you have a p-type semiconductor, which means it has more holes because unlike the pentavalent elements, the trivalent elements are acceptors. So they cause the combination to be more of to have more of holes than normal. So because of that, we have that the N-type semiconductor has a majority charge carrier of electrons. Electrons are the majority charge carrier. And in a p-type, the majority charge carriers are holes. When an N-type and a p-type semiconductor are put together in this format, N-type and p-type, you have what you call a p-n junction at this point. A p-n junction. The movement of electrons from the N-type to combine with holes in the p-type forms a layer in between them in this p-n junction. And this p-n junction, because this layer formed in the p-n junction, is called a depletion layer. A depletion layer. Whenever energy is being passed into the p-n junction to change the shape of the depletion layer to either make it wider or make it slimmer, we call that biasing. So whenever you try to make the depletion layer thinner, we do what you call forward biasing. That's what you call a forward biasing. And whenever you try to make it wider, you call that reverse biasing. Let me draw that up for you. So I'm going to draw a mixture of a p and an n type semiconductor to form a p-n junction connected with a battery. If you connect a battery like this to the p side, this is the battery. This longer side of the battery is the positive side and the shorter side is the negative side. When you connect it like this is called a forward biasing because this negative repels the electrons in the n-type semiconductor and moves them towards this direction. And this positive repels the holes in this direction, in this p-type, and moves them towards the negative, causing the depletion layer to decrease and causing conduction to be possible here. But when you connect it the other way around, with the positive facing the N and the negative facing the P, the positive attracts the electrons in the N-type semiconductor here, and negative attracts the holes in the p-type semiconductor here, causing the depletion layer to get wider, preventing conduction. The p-n junction are the basics of semiconductors, like the diode. Here we have a diode, and the transistor. Check out more videos on this channel to learn more about diodes, transistors, and some other semiconductor devices. Don't forget to like and subscribe. Bye for now.